morning, dear students. Hope so you are fine and enjoying these digital classes nowadays. So this is your chemistry period, unit solid state we are doing, and welcome to digital classes under theme Samay 10 se 12 wala har ghar bane Pathshala. So today on 28th April, I am going to start a new topic, as in the last topic we have done up to density of crystal we have done. So after taking feedback from students, it is seems that you are getting whatever we are teaching. That is wonderful. And as yesterday we have conducted one online live test, so response was good. But here I want to appeal all the students that please attend these kind of tests, as yesterday out of 29, 18 students were present and they were looked seriously also, but as some of the students they were not there, so it is my request from them. This was the first time, that's why I'm leaving you, but next time if you will see non-serious, so I need to call you, I need to take some record, some strict action. Okay, so please cooperate us and please follow the instructions whatever we are passing. So without wasting any time, let's start the topic, imperfections in solids. This is our new topic, imperfections in solids. It is also known as defects and its types. So dear students, what is imperfection? Perfect, you know, but is perfect, which is in every sense mean best. Okay, so here imperfection is which is not perfect. Which is not perfect means somewhere the crystal that is have defect. Okay, so generally what is happening, let me tell you, an ionic crystal which has the same unit cell that contain the same lattice point throughout the whole of crystal, and that kind of crystal is known as ideal crystal. It means that any ionic crystal which is having same unit cell containing in same lattice point, it means that if crystal lattice having same unit cell and there is no even single atoms defect, that kind of crystal is called ideal crystal. But what is happening generally, this kind of ideal crystal is exist only in absolute zero temperature, 0 Kelvin temperature. Okay, at any temperature which is above 0 Kelvin, the crystal have some departure from complete order arrangement. It means that it is now is very difficult to grow a perfect and ideal crystal. As the increasing temperature, the defect is increasing. Okay, so any deviation from completely order, let's talk about the definition. Any deviation from completely order arrangement of constituent particle in a crystal, that is called disorder or defect in simple word. Okay, so due to some impurities, these defects are arise due to some impurities. So we have generally different types of defects. So there are generally two types of defect, point defect and line defect. Point defect is basically when one crystal is there, in one crystal where is one atom, and around this atom if any defect is there, that kind of defect is called point defect. Whereas line defect is called the complete defect in complete line. Okay, but this kind of line defect we are not studying in this year. Point defect is our focus, and just focus on point defect. Point defect is what? It is the defect that around a point or an atom. Defect around a point or an atom is called point defect. So there are two type of crystal, non-ionic crystal, ionic crystal. So basically non-ionic crystal is having two type of defect, vacancy defect and interstitial defect. And ionic defect have three type of defect in stoichiometric crystal, defect in non-stoichiometric crystal, defect in impurity defect. Okay, so basically all these defect is under classification. So today's focus should be classification only. So let's discuss with start with the point defect. What do you mean by point defect? Let me define the defect which arise due to the irregularity or deviation from ideal arrangement of atom around a point, or you can define it in a different way. An atom in a crystalline substance are called point defect or atomic imperfection. If there is some disorder or disturbance in atom in a crystal, that kind of defect is called point defect. Suppose you can see here, these are one missing of atom, defect is there in atom, particular atom, that kind of defect is called point defect. And whereas line defect is what? The defect which arise due to irregularity or deviation from ideal arrangement in entire row defect is called line defect. Okay, so in point defect there are two type of defect, vacancy defect and interstitial defect. Vacancy defect is what? When some of the lattice site are vacant. Dear students, when some of the lattice site are vacant, let's study this from book. When some of the lattice site are vacant, lattice site are vacant, the crystal is said to be vacancy defect. So you can see here, if you will see in a crystal, these are the atoms, or all the atoms are in a regular pattern except this and this. If there is missing of, if this atom is missing from this particular arrangement, that kind of missing leave a vacant space, that vacant is called vacancy defect. Okay, so vacancy defect is due to thermodynamical defect, because as the temperature will increase, some atom will vacant, miss from this position, and called vacancy defect. Second, interstitial defect, when some constituent particle, constituent particle mean atom, ion or molecule, which occupy vacant interstitial position, mean it is not missing now. Here it is missing, but here it is not missing, it is just shifting from its original position. It is shifting from its original position, and the atom is coming in the interstitial side. Interstitial side, the gap which is between two atoms, the space which is between two atoms. If any atom is coming in between that kind of defect is called interstitial defect. But generally these two type of defect is occurring only in non-crystal, non-ionic crystal. Non-ionic mean where it is not positive because of cation and anion. Okay, but when we will talk about ionic crystal is specially made up of one positive and one negative type of crystal. So ionic crystal is called electrovalent crystal also. It is most ideal crystal also. So the defect in these kind of crystal is of three type. Defect in stoichiometry. And what is stoichiometric compound now? Are those in which the number of positive and negative ion. Now relate. Earlier I said ionic compound are positive and negatively charged, and now stoichiometry word will come from the positive and negative, where number of positive and negative ions are exactly in the ratio, indicates by their chemical formula. Mean AB, if AB type of formula is there, so A is positive, B is negative in this, and this defect is there are different types of defect, and two type of main defect is there, Schottky and Frenkel. Dear student, this is very important. I mean, most of the time question is coming, differentiate Schottky and Frenkel defect. The defect is very simple. In Schottky defect, it was discovered by German scientist Schottky in 1930. That's why named defect Schottky defect. It arises if some of the atom or ion are missing. If some of the atom and ion are missing. So we will see here, if some of the atom and ion are missing, so that kind of, this is an ideal crystal. There is no positive negative ion missing. But in Schottky, particularly we will see here, you can see positively charged particle is missing. Here from here negative charge particle is missing. If positive charge missing, cation missing, we can see. If negative charge missing, anion we can see. So this kind of defect is called Schottky defect. Whereas Frenkel defect is the defect discovered by Russian scientist Frenkel in 1926. It is when an ion is missing from its normal position, and not missing, it is occupying an interstitial. Okay, so here also some missing is there, but those missing ions are found in the interstitial part. So it is, you can tell, like, you can relate it like this way. Schottky defect is like a vacancy defect, and Frenkel defect is like an interstitial defect. Okay, but that is in vacancy and interstitial in non-ionic, but Schottky and Frenkel is in ionic defect. Okay, so the condition causing Schottky defect, what is the condition that caused by the Schottky defect? High coordination number, because these are missing, the coordination number will be high, and ions is almost similar in size. Ions are almost similar in size, because if one positive is missing, so one negative is also missing. So most important, the example NaCl, KCl, KBr, Cg, M chloride, silver bromide, these are those ionic solids which have Schottky defect. Okay, and its density is markedly lower. So Frenkel defect is basically, it will coordinate number is low, and anion are much larger in size than the cation here. So silver chloride, silver bromide, you can see silver bromide here also, silver bromide here also. It means that silver bromide is common, silver iodide and zinc sulfide. Okay, so these are the examples where this Frenkel defect can be arise. So these are the, so question is coming basically difference between. So you will write and you will learn also, differentiate between Schottky and Frenkel defect. It is the produced because of missing of atom or ion from the normal crystal site. It is the shifting of displacement of the normal site to interstitial site. The presence of Schottky defect lower the density. It is not affecting the density. It is generally shown in ionic solid where is high coordination number. It is generally found in where lower coordination number. So example is this. Now second is point defect in non-stoichiometric. So this we have done. Vacancy defect we did, interstitial defect we did, ionic crystal in stoichiometry we did. Now defect in non-stoichiometry. It is a little bit long, and further divided into so many. First, let's discuss about the types. Non-stoichiometry. Now, where number of cation and number of negative ions doesn't form in a fixed ratio, that is called non-stoichiometry. So, two type: metal excess defect. As name is itself describing metal excess, it means that in this particular type of defect, metal is excess. So otherwise, how metal will become excess? Metal is positively charged always. Okay, metal is always having electropositive nature. How metal will be excess in any crystal? That can be because of two reasons. One is anionic vacancy. Anionic vacancy means somewhere anion is missing. So what left? The pair of anion is cation, so one extra cation is there. Due to that, metal excess is there. Second, presence of extra cation. Now positive and negative, normal condition, positive and negative is same, but somewhere from outside any other extra cation came, so that also can cause metal excess. The metal deficient is obviously now opposite to this. Here what will happen? Cation vacancy is there. If one positive charge will miss, so obviously metal deficiency is there. Or otherwise somewhere from outside any extra anion came, so it will also cause metal deficient defect. In future, we will study in this same topic the magnetic properties of crystal, in which we will discuss about semiconductors, electrical properties. Semiconductors are two type, N type, P type. You have studied in physics also. So N type of semiconductor caused due to metal excess, P type caused due to metal deficiency. Okay. So third type of impurity is impurity defect. So dear student, impurity defect is what? Now somewhere there is no any metal deficient, metal excess, or missing of anion, missing of cation. There are some extra impurities which is coming from external source. That impurities are there somewhere inside the crystal. Due to that, the crystal color will change. That crystal color will change, and that impurity is called doping. Okay, that word is called doping. And what some of the definitions are there? Doping is what? It is the addition of some impurities, okay, to make the insulator semiconductor. Second, epicenter word, especially it came from, sometimes this question is also coming in 1 marks. What do you mean by epicenter? So epicenter is basically we have studied in anion vacancy. So what is epicenter? The electron that trapped in an anion vacancy. Any electron which trapped in anionic vacancy is called epicenter. It is epicenter, which is from German word mean Farwenzenter, meaning color center. It means that sometimes crystal is looking, showing some color, yellow color. It impart yellow color when the reflection is there. It means that is due to the epicenter. Okay, so these are some important definitions, terms that we are going to study, and sometime in 1 marks these kind of terms are asking, and from where. And one more, that is fool's gold. What is fool's gold? Sometimes crystal is giving some, due to some reflection, some gold type of appearance. Crystal is generally transparent, but sometimes when due to impurities, due to defect, it is giving some color is like gold. So then people are thinking sometime inside the earth crust, this is gold, but that is not gold, that is crystal, defected crystal. So that's why it is called fool's gold. Okay, so hope so you understood this topic, and now I'm sharing one PDF to you. Go through the PDF and use this video just for understanding. Okay, so that's it for today, and till then, take care, stay home, stay safe, and keep watching this video. Thank you. Have a nice day.